Everyone. The series of problems on network theorems, I have taken up a problem on superposition theorem. And the problem goes this way. We are supposed to find I1 using superposition theorem for the following network. Let us try to have a look at the network. I'll write the network with you. What I would suggest viewers is that they might as well do the problem independently if they have understood the theorem, and then they can check for the solutions by playing the video. That would be a proper method of learning if at all they're interested in learning things well. Simply seeing the video doesn't help. We need to work it out for ourselves and check whether we have understood things properly or not. Anyway, let me write the network. Hope you are all of you are following the videos. I'm more into numericals or problems than on to theory. Yeah, this is how the network looks like. I'll put the values now. We have a current source, an independent current source of 1 ampere. We have a resistance of 6 ohms here, and there is a resistance of 8 ohms and 4 ohms here. And this diamond-shaped figure, as I've been telling in all the videos, that it is a dependent source. We have a plus and a minus, which goes to say that it is a dependent voltage source. And the magnitude of this source is 2 times Vx. It is a voltage-dependent voltage source, but we need to specify what is this Vx. In the problem, he says this is Vx with this is the polarity. Okay, so we are expected to determine current I1. The problem says this is the current I1. We are expected to evaluate this current I1 using superposition theorem. So we have already done problems on superposition theorem, but in this video I'm trying to cover superposition theorem having a dependent source. So this voltage dependent voltage source is something that I have taken up in this particular video. We have an independent current source, we have a dependent voltage source, we have resistors, and this is Vx, and this is the current I1. Let us try to give one more current. Let us try to designate the current in 8 ohm branch as, let us say, I will call this current I2. This is my convenience. Okay. So how do we do problems of this nature? We know that in superposition theorem, we need to take one source at a time and evaluate the contribution of that source for the response in various elements of the network. Then we try to take another source at a time, deactivate the first one, take the second one, and find out what it contributes in terms of response in various branches. Then if you have only two sources, you tend to superimpose the addition of the two responses. You club the two responses and you will arrive at the response which would have occurred if both the sources were acting together. That is what it means to say. Now, in this particular situation, this I1 and I2 we recognize as the response in the element of 6 ohms and this element 8 and 4 in series, this particular branch, respectively. Okay, these are the responses due to the dependent source and also the independent source. Okay, now we know how to do with the independent sources. We will deactivate this dependent voltage source. Then we will try to find out. Let us try to do step by step. So our first step would tell us to have only one source on. Step number one, to only 1 ampere source is on. Only 1 ampere source is on. Alright, so how will the network look like? Let me copy this network. Let me take this network. Let me copy it down. I'll paste this network here. I will have to remove the dependent source, right? So it's a voltage source. So we try to short the terminals across which we have the source. Okay, so I'll do that part. I'll try to remove this voltage source, dependent source. All right, I'll replace it by a short circuit. I'll use a color so that things are clear. Okay, so I have removed the source and I have replaced it by short. Now, what is to be observed here is the currents that are flowing now in the network cannot be called I1 and I2. Why can't they be called I1 and I2? Simply because I1 and I2 are the currents due to both the sources acting together. Now, in this network, we have only one source acting. So, the current cannot be I1 and I2. So, instead, what we do is, we will try to take a subscript, rather a superscript. We will call this I1 dash, I2 dash. So, we need to be a little careful with this. Alright, I can even use Vx dash here. The voltage that is developed now is Vx dash. What is Vx? Vx is the voltage that gets developed across 4 ohm resistor when current I1 and I2, rather I2 flows through 4 ohms. Now the current through 4 ohms is not I2 but it is I2 dash. So obviously I cannot have the same nomenclature. The magnitude is now different. So I have to give a different name to it. So I would prefer to call it Vx dash. These things have to be clearly followed. Otherwise it's going to be a complete mess up. Alright. Now how do we see this network? We can evaluate these currents very easily because 8 and 4 ohm resistor, these two resistors, they are in series because they carry the same current, and the 6 ohm and this 12 ohm combination, they are in parallel. It is a simple series parallel network wherein we can apply current division rule and evaluate I1 dash and I2 dash. Let's go ahead. Let me evaluate these two currents. So from current division rule, rather by current division, I will write I1 dash as equal to 1 ohm is the total current entering the junction. What I mean as junction is this point. Okay, these two are in parallel. This is the junction at which it enters. So that is the total current because it's a current source. Current source would give 1 ampere current. It will come up to this junction and it will split into 6 ohm path and 12 ohm path. It will divide into these two paths and recombine and get back. So current division rule is total current that enters the junction multiplied with the resistance of the other branch through which you are not calculating the current, that is 12 ohm, the other branch, divided by the total resistance of the two parallel paths. So I have to add all the two. 8 plus 4 is 12 plus 6 is 18 ohm resistance. This is how you evaluate I1 dash. This comes out to be 0.667 ampere. Alright, now what is I2 dash equal to? So I2 dash can be simply subtracted from 1. So we can simply calculate 1 minus 0.667. So whatever remains from 1 will flow through this branch, right? So I1 dash is 0.667. So current here is 1 minus of I1 dash. So that comes out to be 0.33 ampere. Okay, so we are able to evaluate the current due to 1 ampere source alone. Okay, so how do we do with the other source? See, the other source that we have is this dependent source. Okay, so we will try to replace the magnitude of this dependent source by some voltage. That's what we will do later. However, we have to consider this source on. This source will be switched off. Switched off condition of a current source is modeled as an open circuit. Why? Because switched off condition means it will not leave out any current through its terminals. No current flows out of its terminals. So no current flows in an open circuit. Hence, modeling of turning off of a current source is represented or is done by an open circuit. So in step 2, I will write now the description which I mentioned right now. Step 2 is we will keep only 2 Vx source on. So one source at a time. Superposition theorem is one source at a time. You should have one source at a time. Okay. So how do we write the network? So I will take the network. I will perhaps take this network only. This network only I'll take. I'll copy this network. I'll paste it. Alright, so I pasted this network. Now what I have to do is, I will have to open circuit this branch. I'll create an open circuit here. Creating an open circuit is as good as removing this wire even. Okay, I will remove this wire also, and then, or else I'll partially remove that wire. I'll take a little bigger eraser and I'll remove this much. I can do that. It is simple enough logic. Okay, now I'm done with the network manipulation. Okay, now what I do is, now this Vx, I will try to replace it with one voltage called V. I'll use a color now. So what I mean is, instead of Vx, I will make this V. I'll use this V now. So, or in other words, I will remove this for the time being, call it V. I'll remove V also. Then I'll write V here. I'll try to write the network first, then we will go with the explanation. Okay, so how is the current flow? If there is a source V, the current flow is from positive to negative. The current won't be in this direction. I will have to remove this arrow. Okay, and I'll have to remove this arrow also. Then, however, we will now put the current in this direction. All right, the current would flow like this. It will flow like this. It'll come back here. It will come back here. Okay. Now, what are the things that we have? This V will leave out a current. This is I1 double dash. This is I2 double dash. And this I can call it Vx double dash. Okay. So, I've done this. So, what exactly we have done is, an important substitution that I have done is let V equal to 2Vx. This important substitution I have made for the ease of the problem. That's all. There is no big deal about it. Now, how do we compute the quantities? How do we get the currents? The current is very, very simple. How do we get the current? It is simple. Everything is in series. The entire thing is in series. Your I1 double dash and I2 double dash both are same. The current in this branch and this branch all are same. So we get the current to be, I'll take the white pencil. So what I mean is, my I1 double dash, which also is equal to I2 double dash. You can call it by any one current. You need not even have to write I2 double dash here, because it is a series thing. That is the current that flows in the circuit. It is a simple series circuit. Whatever current that 6 ohm carries would be flowing through 8 and would be flowing through 12. So this I1 double dash now is equal to the voltage that I have replaced, V, divided by the total resistance of the circuit, that is 18. So this is one result I have. Okay, this is the current. So in other words, this is the current that is flowing in all the three resistors. Now I will try to superimpose and find out the total current. So what do? Now I have evaluated the currents, right? So what am I supposed to evaluate? I was supposed to evaluate the currents in both the branches. The problem says find out this current, right? This current has to be evaluated by superposition theorem. So we were able to, the current through 6 ohm resistance has to be evaluated. Now I have evaluated that current due to 1 ampere source. I have found it to be I1 double dash, I1 single dash. And due to the other source, it is I1 double dash. I have evaluated both. But then we have to remember that this is in the form of an unknown voltage V. So we will try to do now. Okay. So now superimposing. Now we will try to superimpose. Superimposing. Superimposing means adding the individual contributions by individual sources or both the sources. Now how do we write? So my I1, which I'm supposed to find, is equal to I1 dash, which is in the downward direction, and I1 double dash is in the upward direction. So I may have to subtract one from the other. Okay, we will look back. How is I1 dash flowing? If you look at I1 dash, the direction of flow of current, it's from top to bottom. Whereas I1 double dash is from bottom to top through 6 ohm. So it is the difference in the current that would be called I1. Now we will substitute. This is 0.667 minus V upon 18. Alright, so this is that particular current. But we need to replace for this V. What is V? We remember V equal to 2Vx. But what is Vx? Vx is something that is the voltage developed across 4 ohm resistor. Across 4 ohm resistor, whatever voltage that gets developed, that is what we call as Vx. So V equal to 2Vx is something we have to bear it in mind. Okay, so we need to evaluate Vx, we need to know the current through this branch also. I2 has to be evaluated, right? I2 has to be evaluated when both the sources are present. So in other words, we need to superimpose the current contribution in this branch due to 1 ampere source and the current contribution in this branch due to 2Vx source, or which we have called it as V. Okay, so to do that, we will try to write what is my I2 equal to. I2 equal to I2 dash plus, you have to understand, this is plus now. I2 dash plus I1 double dash. We will go back to the circuit and see what we have written. Is it correct? So I2 dash is from top to bottom. I1 double dash is also from top to bottom. So insofar as this current through this 8 and 4 branch is concerned, both the currents are flowing from top to bottom, hence we add the two currents. So you should know when to add and when to subtract. This is 0.33 and this we have found it to be V divided by 18. Alright, so we are able to get both the currents. Okay, so but what is Vx? Why do we want Vx? Because we need to find out, we have to get rid of this V, right? So now we will calculate Vx. What is Vx? Vx is the potential difference developed across 4 ohms, which is equal to 4 into the total current. What is the current? Current we have called it as I2. So this is 4 into 0.33 plus V divided by 18. This comes out to be equal to 4 into 0.33 plus 2Vx divided by 18. Okay, so we will try to simplify this. So we have Vx on one side, we have other Vx on another side. I suppose you can see Vx equal to 4 into 0.33 plus 2Vx divided by 18. So you open up the bracket, we simplify. So we get from the solving this, we get Vx equal to 2.4 volt. Alright, so we are able to get this as the voltage. Okay, so now this is my Vx. Okay, now what is V equal to? We have written what is V equal to. If we look back, we say V equal to twice Vx. Okay, so we will try to evaluate what is this V. V equal to twice Vx. This is 4.8 volt. This is what is my V. Alright, this is what is my V. Okay, now having found V, we will go back to the expression and then find out what is our current I1. So therefore, I1, we have found this, right? This is equation 1. This is 1. We will replace for V in equation 1. Therefore, equation 1 becomes what will happen to equation 1? Equation 1 becomes I1 equal to 0.667 minus 4.8 divided by 18. This comes out to be 0.4 ampere. And there, so my problem is over. Now, the current through this resistance, therefore, I1 equal to 0.4 amperes. So, this is the current in that 4 ohm resistance when both the sources are present. Okay, you can solve this problem by any other method and then you can verify if what we have obtained is true or not. Okay, one can do it by nodal method, one can do it by mesh method, and one can get whether the result we obtain is it correct or otherwise. We can conveniently do. Should we try to verify? Maybe we will try this exercise and see what will happen. Okay, just verification. Verification is I will try to solve the same problem with a different method. All right, so let me pick up the network. Copy. I hope the viewers are following carefully what I'm doing. Okay, so what I'm trying to do is I will not call them branch currents now. I will solve it by mesh method and see what will happen. Okay, that should be done. Okay, now if this is the network, I'll try to solve it by mesh equation. Let's try to see how the mesh equation would be. Okay, so let me use a current here in this branch, in this mesh rather. This mesh will essentially carry, I'll call this current, okay, this current as I1. Is the shape not proper? Okay, let me do this way. Okay, I think that's better. Now I'll try to use this partial eraser and I will clear this match portion so that what I mean is I'll try to have this current. I'll call this current I1. Okay, I'll call this mesh current I1. So obviously in this mesh, I will have 1 ampere current. In this mesh, I will have 1 ampere current because of the current source that is present. This current source will pump in 1 ampere current, and 1 ampere current we will assume it to be in the mesh 2. I have taken an anti-clockwise current for convenience. That's all. You should know how, you should be able to, flip the directions. The understanding should be there. Okay, now we will try to write the equation. How do we write the equation? Because mesh comes out to be easier. We will write the sum of the resistances in the first mesh. How much is that? It is 8 plus 4, 12 plus 8 is 6, 18. So 18 times I1. Okay, and the potential difference due to the other mesh current, if it was clockwise, we would have taken it as negative. Now we have taken anti-clockwise current, that is 1 ampere current is anti-clockwise current. So we take this as the plus 6 ohms. Plus 6 into 1. 6 ohm resistance into 1 ampere, that is 6 itself. Okay, that should be, and plus 2 Vx equal to 0. So this is the equation we have. This is the simple equation we have. So we will try to write this much. This is 18I1 plus 6 equal to minus 2 Vx. But what is Vx? What is Vx? If we look at this Vx, Vx is the potential difference in this direction. That is the potential difference. Okay? It is 4 times I1 is the magnitude. Vx is 4 times I1. That is the magnitude of current. So if we can substitute this to be equal to, this is 18I1 plus 6 equal to minus Vx is I1 is flowing in this direction. I1 is flowing in that direction, but Vx is in the opposite direction. So I will have to call this as 4 into I1. Okay? Into 2 rather. I have left out this 2, right? This is 2 into minus 2 into 2 into minus 4 times I1. The polarity has to be properly understood. This is 89. This is 4 to the 8. So on this side, if it go, this is now 8 I1, 18 I1 plus 6. Now I get 10 I1 equal to minus 6, or I1 equal to minus 10 by 6. This is equal to minus 0.4 ampere. Okay, so what do I understand by this? This is I1. This is an interesting way of doing this problem. Okay, I've done it by mesh analysis, and now I'm getting the result to be I1 equal to minus 0.4 ampere. Okay, so what does that supposed to indicate? Look at the direction of current that I have assumed. I have assumed the current in this element to be this is the mesh current to be 0.6 ampere. I'm sorry there. This is 0.6 ampere, right? This is 0.6 amperes. Okay, that is the current I1. Now I'm interested in the current in this branch, right? I'm interested in the current in this branch. So he's telling this is the direction of current he has given. What is the direction of current he has given in the original problem? I1. This is the direction of current he is talking about. Okay, this is my current. I should have called this current instead of I1. I should have called it something else. Anyway, that shouldn't matter as such. This is I through 6 ohms. We need to compute, right? So we need to compute this I through 6 ohms. So what is I through 6 ohms equal to? So I through 6 ohms, typically I through 6 ohms, from the circuit diagram, both the currents are flowing in the same direction. So they get added up. This is equal to 1 ampere plus I1 ampere. Both the currents are flowing in the same direction, but we have found I1 to be minus 0.6. So 1 minus 0.6, this comes out to be 0.4 ampere. Okay, so the current in 6 ohm resistance when both the sources are active is equal to 0.4 ampere. See, we have done it by mesh method. So mesh method is simple. Quickly we were able to do, whereas our superposition method involved 2 steps, which is little elaborate. So when to use which method, one has to be little careful, and a clear understanding of various concepts would help one pick up the method. You can even solve this by nodal method, but mesh method appears little interesting and easy. Okay, I suppose you're with me, you're able to understand how we have done. Okay, so if you want me to, or if you feel, let's have a quick recap. I'll have a recap. Okay, it's preferable to have a recap. So how did we do the problem? So the problem contained 2 kinds of sources, an independent source and a dependent source. We considered one at a time as per the method that we follow for applying superposition theorem to networks. So we considered one source at a time, that is 1 ampere current source first, then this source is a second step. So 1 ampere current source, the distribution of current, simple. We were able to get the current by current division. We were able to get the current I1 dash to be so much, I2 dash to be so much. We used different notations for the currents and the voltages because of the presence of only one source. Alright, we were able to get this. So we have 2 Vx source on. We could have maintained 2 Vx here. For simplicity, I have replaced it. Ultimately, we are going to re-substitute for 2 Vx as V. We have done that. Anyway, now that I have called this V, we will call this V, we will try to compute the current. Now, the current would circulate in this path. It is simple current, one current, which will flow through all the resistors. It is I1 double dash or I2 double dash or whatever we call it. That is equal to V divided by 18. Okay, we have added the resistance. 10 plus 8, 18. So, we now found the two currents. So, we try to superimpose the currents. I1 equal to I1 dash minus I1 double dash, because one I1 double dash is in the upward direction. This current, I'll use the color. I'll use some color. Okay. So, I1 dash is in this direction. Okay. I1 double dash is in this direction. Hence, we subtracted one from the other. Okay, as far as that element is concerned, the current in once is flowing from top to bottom, another it is from bottom to top. So we have subtracted the two currents, we get this expression. Okay, but we need to substitute for this V, and we know that V is equal to twice Vx. That is something we know. We know V equal to twice Vx, we know. But what is Vx? We also know that Vx is the drop across this. So you need to find out the current in this branch through 4 ohm resistance when both the sources are active. So again you have to superimpose for I2. So I2 equal to I2 dash plus I1 double dash. You will get this to be so much. So Vx is something we first evaluate. Vx is equal to 4 times I2. This is the 4 times. How did we get? This is the 4 times resistance times the current. 4 times I2. So I2 we have substituted. We got this much. So we again substituted for V. We got this much, 2Vx. Now, we got an equation wherein we get Vx. So, we can solve for Vx. So, once you get Vx, you can compute what is 2Vx, and this is the voltage. So, having computed V, we go back to the equation I1, because I1 is of interest to us. We will substitute, and we were able to get the current as 0.4 amperes. Here completes the problem. We're done with the problem. Basically, I just wanted to show that by mesh method, this works up in 4 steps. You get only one equation and one unknown. That's it. Right? Rather, 2 unknowns you will get. And you can solve it by mesh method. And you are able to see that from both the methods, if you can see, this is 0.4 amperes. This is the current. I'll pick up the white color only. This is the current through 6 ohm resistor. Right? And that is the current through 6 ohm resistor. This is equal to I through 6 ohms. Alright, so we've done the verification. Okay, so somebody requested me to make videos on superposition theorem. They said it's not very clear. I said, okay, let me try. Let me do one more problem before moving on to the transients. I intend doing problems on network transients. Very, very interesting chapter, and often students find it little difficult to understand it. Otherwise, these things are, theorems are simple step-by-step procedure. You follow, be little careful with the values, you will be able to get the answers right. Okay, thank you so much for watching. And let's catch up on our next video. Stay safe and